Hi there, students. Welcome to the first pre-calculus midterm review video. This video will cover the topic of functions, and what I mean by functions, we'll divide that into four little topics. The first one is just going to be the domain of a function. Then we'll talk about transforming or transformations of functions. Next, we'll talk about increasing and decreasing functions, and finally, we'll talk about the composition of functions. Okay, so let's get started. The first one is first little mini topic is about the domain of a function. Now, when you're trying to find the domain of a function, basically, you want to look for what doesn't work, such as taking the square root of a negative number or dividing by 0. Those are the two things that you'll be concerned with in finding the domain of a function. Of course, as there's many different kinds of functions, there could be other rules as well. But let's just focus on these two for now. For example, if we have a function that we're trying to find the domain of, such as we'll take f of x equals the square root of 7x minus 2, and in this case we're clearly concerned with the square root, so we have to keep in mind that we can't take the square root of a negative number. So all we have to do is make sure that 7x minus 2 is greater than or equal to 0. And solving that inequality there gives us x is greater than or equal to 2/7. Therefore, the domain of the function here is just from 2/7 to infinity, everything greater than or equal to 2/7. Well, let's take another look at a different function here. Let's say g of x equals x minus 2 over x plus 4. Well, in this case, the other situation that we mentioned earlier is present. We do not want to divide by 0. So any number that makes the denominator of that fraction equal 0 is a number that we have to exclude from the domain. And clearly, since x cannot equal negative 4 here, then the domain is all numbers x not equal to negative 4. And of course, negative 4 is the only number that will make the denominator equal 0. Okay, well, let's move on to the next topic then, and that is the transformations of functions. All right, and basically that's all the different little ways we can shift functions around, such as if we have some function named f of x plus or minus k, that is where k is just some real number, f of x plus or minus k is a horizontal shift of that function. Horizontal translation, you could call it. Plus means shifting to the left, and minus means shifting to the right. So it's a little bit counterintuitive there about that. Next kind of transformation is f of x plus or minus k. Notice the plus or minus k is outside of the parentheses now. And that is a vertical shift. In this case, plus a number means shifting up, and minus a number means shifting down. The next kind of transformation that you'll need to know is f of negative x. That is, if you switch the sign of the x value, that is a reflection across the y-axis. So reflecting over the y-axis. The other and the last kind here that we'll be concerned with is negative f of x, and that is simply a reflection over the x-axis. Okay, so let's just take a look at an example using some of these rules. And of course, there are other kinds of transformations, but these are the four that we'll mostly be concerned with here for now. Let's say, for example, suppose a function g of x is shifted 5 units up, 2 units to the right, and is then reflected across the x-axis. All right? So just to summarize that, you have some function g of x, and it has been transformed by shifting up 5 units, shifting to the right 2 units, and then reflected across the x-axis. And your job will be to write the new function. Well, putting all those things together one at a time gives you this expression right here of g of x, negative g of the quantity x minus 2 plus 5. All right, and we can see that all three of those transformations mentioned up above are present in this new function of g. For example, reflecting across the x-axis, that's what the negative sign did. and shifting it 2 units to the right, that's where we see x minus 2. So there's our horizontal shift. And then finally the vertical shift, shifting 5 units up there with the plus 5. Okay, well, let's keep on moving here. The next topic we're going to talk about is increasing or decreasing functions. And these are two very simple concepts in terms of just the intuitive understanding of these words. Simple, I should say. For example, increasing just means going up. That is left to right, going up. And decreasing means going down, once again, from left to right. For this little video here, we're going to focus on exponential functions. Okay? So there are these two words, increasing and decreasing, can describe many different kinds of functions. It's more complicated than this little video will cover, but we'll just talk about some exponential functions here. For example, let's take the function y equals 2 to the x. Clearly, if you can visualize the graph of that function is increasing. No problem there. Well, what about maybe some kind of transformation of that 2 to the x, such as y equals 1/2 to the x? Wow, is that a transformation? Well, in a sense it is, and you can clearly see by the graph that that function is decreasing. The reason I mentioned it's kind of a transformation of 2 to the x is that 1/2 to the x is the same thing as 2 to the negative x. So in a sense, y equals 1/2 to the x is a reflection across the y-axis of y equals 2 to the x. Let's look at another one. What if we take y equals negative 2 to the x? Well, there's a reflection across the x-axis, and clearly that function is also decreasing. No problem there. Last example where we combine all of those different transformations together, y equals negative 2 to the negative x. Well, that's a reflection across the x-axis and the y-axis, and clearly when you look at that function is increasing. Okay, so being able to visualize those transformations and then determining whether or not a function is increasing or decreasing is going to be a useful skill here for our midterm exam. Well, let's keep moving. The last topic that we're going to talk about in this video is function composition, which is, of course, a very special way to combine functions. Here's a decent little description of what function composition is. It's when one function is combined with another function by using it as the input into another function. We've done this several times, but let's take an example here. And let's say that we have two functions, f of x equals 2x minus 5, and g of x equals 3x squared minus x. All right, so we have a linear function and a quadratic function. And what we're going to do here is find g circle f of x and f circle g of x. Okay, so we're using this circle notation here in this video. But of course, g circle f of x is really just another way of saying g of f of x. So you can certainly think of it that way, and it's nice to do that because then you can clearly see that f of x is being used as the input into g of x. Okay, so look up again at our functions there. F of x is 2x minus 5, and we're going to use that expression, 2x minus 5, as the input into g of x. And so what that looks like when you kind of spell it all out is 3 times 2x minus 5 squared minus 2x minus 5. And there's a little bit of algebra here to get through on this one. Just kind of in the way of reviewing, when you square that binomial 2x minus 5, all right, this is how that works out. So just kind of being careful about that is an important part of this algebra. And then, of course, we have minus 2x plus 5 because the negative sign switches the negative 5 to a plus 5. And then just combining all our like terms finally gives us this quantity here, 12x squared. Whoops. Well, there you saw it. You can slow it down and stop it again if you need to. If we switch this around and do f of g of x, or f circle g of x, and rewrite that as f of g of x, we can see that that's going to use g of x as the input into f. So that'll give us 2 times the quantity, 3x squared minus x, minus 5. And that's a much simpler thing to figure out. 6x squared minus 2x minus 5. And in both cases, we end up with a quadratic function as our result. And so there you go. There's a couple of quick examples of function composition. And that puts us at about a little over 10 minutes for this video, which I think is long enough, don't you? Anyway, enjoy the rest of your day, and watch out for the next video, I should say. And be sure and take the little online quiz regarding the topics covered here in this video. Should be pretty easy if you watch the video, and so it should be some easy points for you. Okay, bye-bye.